All right, so at this point in the Do Nothing Machine T-nuts, I have blocks squared up. I have two of these squared up. Then at this step, I'd like to mill in the slots. So just to kind of give you an idea of what we're going to be cutting away, if I look from the top as I see the print, basically I'm going to be cutting away this area right here and this area over here. And I'm leaving the center alone. And then from the side, what it's going to end up looking like is I'm going to be cutting down this area, and we can kind of see what I'm referencing here with the print, and then from the end it would actually end up looking like this T-slot. So I cut away this spot and this spot, and you can kind of see that the T-nut is starting to take shape. And so in order to do that, I need to have the mill set up, I need to have the block in the mill, and I need to have the edge finder set up. So in a minute I'm going to have that to kind of demo, but basically what I want to do is have it in my vise. I want to edge find. Now I know it has this come from the bottom left corner on the print. However, since it's a symmetrical part, we can kind of choose if we want to come from the top or the bottom. And since this is going to be our fixed jaw at the top, I'd like to edge find there. And so essentially what I'm going to do is I'm going to put this in the mill, bump my edge finder off, move it over, zero it out, and I'm going to have the center of my tool over the top edge of the part. Now I'm actually not going to worry about finding the left or right side, because all I'm going to be doing is traversing my cutter on X and not on Y. So I'm just going end to end on X. I don't really care where that location is, because I'm going to go clear through the part. So what I need to worry about is how deep am I going to make this cut, and where is the location of this cut going to be. So first thing is the location. Location, if I look on this part of the print, okay, the right side view, I can see that the step should be 250 thousandths in from this side and 250 thousandths in from this side, basically symmetrical on the step right there. So that's a ½ inch total that I'm cutting right there. And you would say, okay, if this is 990 thousandths total width, I'm going to subtract this, and that'll give me the overall dimension that I'm left with up there. So I'm going to take 250 thousandths off there and 250 thousandths off there. And I'm going to go to a depth. If we look at this view right here, basically if I have an overall thickness of 525 and I want to leave the bottom step at 250, well, that means I'm going to take off this remainder. So I would do 525 minus 250. That should be 275 thousandths is how deep I'm going to bring the step. And so I'm going to set the machine up, and then I'm going to show you guys how we're going to set that up and take those cuts. Now before I get started, I just wanted to make sure that we kind of went over what numbers we're going to be using when we touch off our cutter and everything. And so I'm going to be using a ½ inch end mill. Now keep in mind, if you use a 3/8 or a 5/8, you're going to have to change the numbers based on the diameter of the end mill. But for a ½ inch, this actually works out really well. And so like we said before, if you look at the fact that the width of this little step that we're going to cut into here is 250 thousandths in from the end. And if we did the math, we would see it's symmetrical over here as well. So 250 thousandths from here to here. And so with a ½ inch end mill, that's actually really nice, because as before I said, I'm going to edge find up on this top corner here, on this top edge, calling this my 0 for Y at the moment. Even though my print has it come from the bottom, I'm going to go ahead and do it up top because it's a symmetrical part. And so when I set my 0 up on this edge, and I use a ½ inch end mill, essentially on this edge right here, I'm going to just end up with my cutter at Y0, because once my cutter is at Y0 with a ½ inch end mill, that means a 1/4 of an inch of my end mill, or half of it, is over into this area making the cut, which is the exact amount that I want. So I use a ½ inch end mill, I have it all edge found on this top edge, and I end up right at Y0. And then just like with anything else, you're going to touch off on the top of the part, and you're going to end up going down until you hit this area right here, which we just said if we did 525 minus 250, the remainder of that should be 275. Okay, so I'm going to go ahead and set up the machine, and I'll show you how to take the cut. All right, so you can see I have in my machine set up. Here's my 2 blocks, and just like we squared them up, because these are the exact same size and we're doing the exact same operation, we're able to put both parts in the vise at the same time, and we can actually go ahead and take a cut down the back edge across the whole width, and then we'll cut it in both pieces, and then we can do the other edge and we'll cut it into both pieces. So just like any other operation, I'm going to go ahead and turn this on. I have my RPM calculated to we're going to be around the 2,000 mark. Okay, and just like anywhere else or any other time, you're going to go ahead and touch off on Z. So first thing I'm going to do is I'm going to bring my part over the top, and I'm going to touch off Z just to get my reference. Okay, so I just took a small cut right there. I'm going to go ahead and zero my Z out. Okay, so that's zeroed out right there. And then, as I mentioned before, basically what I want to end up with is my cutter, my y-axis at 0, but I want to creep up on it. And so I'm going to go ahead and go behind the part. Because I want a conventional mill, I'm going to start off on the right side. And I'm going to crank down 100 thousandths on Z to start my first cut. So I'm going to go ahead and I'm cranking to 100. I zeroed it out, now I'm cranking to 100. Okay, and I'm going to go ahead, touch it off on Y. Okay, so I touched it off on Y, and I just want to show you, see, if I look over at the digital readout, I'm exactly at 250, and that's because my center of my tool is zeroed out on that edge, and so since I'm the diameter of the cutter away, in this case a ½ inch, I'm going to be at 250 or negative 250 because I'm touched off on the side right now. So I'm going to go ahead and I'm going to go in about 50 thousandths. So I'm taking 50 thousandths cut on Y and about 100 thousandths cut on Z. So I'm going to come right back here and show you the cut. And I'm going to lock in my Y axis so it doesn't move on me as I'm traversing on X. Okay, and so I'm taking this cut. It seems to be cutting okay. Make sure you inspect your cutter before you start. And I'm going to go all the way down. And I'm doing conventional milling. Okay, so once I'm there, I'm going to go ahead and go back. And I'm going to creep in. So now I was at 200. I took 50 thousandths. And so I'm going to go ahead and come in another 50, so about 150 on my y-axis. Take this cut, come right back. I'm going to go in some more. Now what I'm going to do is I'm going to go ahead and take a little bit bigger cut, but I'm not going to go all the way to 0. So right now I'm going to go ahead and go to about 50 because I want to be double checking, but right now I'm just trying to get some material removed. Okay, so basically I went to 50 on my y-axis, and you can start to see that step starting to take shape. And so we can kind of zoom in there and see that step taking shape. And on Y, I'm at about 49, 50 thousandths. So I still have about 50 thousandths to go, but I'm going to go ahead and increase my depth of cut right now. So I was at Z 100. I'm going to go ahead and go to Z 200 because I know I want to end up taking about 275 thousandths off. And I'm going to go ahead and take this cut, make sure my y-axis is locked down. Okay, so I'm at 200. I'm going to go to 250. What that should leave me is about 25 thousandths in Z and about 50 thousandths in X to go. So now before I get going, just to kind of verify, I want to go ahead and just double check, see where I'm at. It's kind of a rough cut on the back, so I'm going to go ahead and climb mill for a second. I'm going to take about a 10 thousandths cut on Y, so I'm at about Y40 now. Take a light cut coming back. Okay, now I'm ready to kind of check it and see where I'm at. Basically what I should be at, if I come up and look at my Y-axis, okay, I should be about Y39 or 40 away. Okay, so I shouldn't be at 250 for that step yet. I should be about 210, which would bring me 40 thousandths shy. And I should be about Z, I should be about 25 thousandths shy on Z. You can kind of see the step starting to take shape if I come over and take a look at it over here. You can see this step starting to take shape. And so I'm going to go ahead and measure that up and verify that what I have left is what I should have left, and then go ahead and take the other. Okay, and so just to show you the finished step, kind of show you on the print as well, rather than trying to measure the actual width of the step, what I've also given you is the distance from the side to basically the back side of the step should be 740, and that works if you measure when you're doing this side or when you flip it into the other side. Basically from the outside edge to the inside edge of whatever step you're working on should be 740. And so if I show you on the caliper, basically this distance right here, the outside edge of the part to the inside edge of this step, and we can see I'm at about 739. Okay, so I'm within tolerance right there, that's no problem. And then for the depth of the step, rather than measuring the actual depth, again, what should be left over is 250 thousandths, as noted on the print right here. So that's what I'm going to measure instead of trying to measure the 275 deep. Okay, so I'm going to go ahead and kind of reposition for a second and show you that. So if I just get in here, and this might not be a bad idea to take it out and deburr it and everything, but I just want to get a good idea before I go pulling it out of there. So I'm going to go ahead, get on that little area, kind of close it down, and you can see I'm at about 248.5. So again, 1.5 thousandths off. I'm within tolerance. That's about where you want to be. Okay, the closer you can get to 250 is the better, but this is definitely within tolerance. At this point, what you can do is you could figure out the math and figure out what numbers you'd have to be at here. But you'll notice, basically, all I really have to do at this point is I can take these parts out, flip them over 180. Okay, of course, clean them all up and everything. But essentially, I can just use these same exact numbers as what I just used because now I'm still working on the back edge. And so I would tighten this down, work on the back edge, and I'd be good to go. So using the exact same numbers. Otherwise, you have to sit there and figure out all the math, which isn't a big deal, but this is just a little bit more efficient way to do it. Take it out, flip it over, and go ahead and work from the back edge. And you can actually see as well, basically what I ended up at was 0 on my y-axis. Okay, and then on Z I ended up at 275, which is exactly what I thought I was supposed to take. Double check along the way, make sure you're doing it correctly, but if you work the math out correctly and touch everything off correctly, it should work out no problem. I'm going to go ahead and knock out the other step and then show you guys what it looks like as a finished T-nut. Okay, now basically what I want to show you is that I did the same thing on the other side, and now I have a T-nut that is complete. I measured and checked along the way, but essentially all I was doing was taking cuts along my x-axis, taking depth of cuts along my y and my z, and coming up with the proper size and shape. And essentially what you're looking for to do in the end is, if this is your base block right here, your new T right into here, okay? And basically you can see that it slides all the way down. What you don't want to see is a bunch of slop right here. It's only designed for about 5 or 10 thousandths of slop. So if you end up cutting those steps too deep in, it's going to reduce the thicknesses and they're not going to match up. And then what happens is when this ends up going for this cross, it kind of goes cocked and hits the other edge, and it kind of binds up in there. So you want nice smooth operation all the way through. Okay, so just like that. And that's what you're looking for.